Preparing for a Docker Solutions Engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is Docker, and how do containers differ from virtual machines? Containers package an application with its dependencies while sharing the host operating system kernel. Virtual machines include a complete guest operating system managed by a hypervisor, so they usually consume more resources and start more slowly. Docker uses namespaces for isolation and cgroups for resource control. Containers provide excellent portability and density, but they are not equivalent to security boundaries provided by separate kernels. I choose virtual machines when stronger isolation or different operating systems are required. While answering, explain images, containers, namespaces, cgroups, shared kernels, hypervisors, startup time, isolation boundaries, resource efficiency, portability, and situations where virtual machines remain more appropriate. Question 2. Walk me through the lifecycle of a Docker container. A container lifecycle begins when Docker pulls or locates an image, creates a writable container layer, and starts the configured entry point process. While that process runs, the container is running. When it exits, the container becomes stopped but remains available for inspection or restart. Logs and exit codes help diagnose failures. Removing the container deletes its writable layer, but named volumes and images survive unless explicitly pruned or removed. Make sure to cover image retrieval, container creation, file system layers, process startup, running and stop states, restart behavior, logs, exit codes, removal, volumes, and the distinction between container and image lifecycles. Question 3. How would you build a secure and efficient Docker image for a production service? I start with a trusted, minimal base image and use a multi-stage Dockerfile so compilers and development tools stay out of production. I pin dependency versions, add a non-root user, exclude unnecessary files with Docker ignore, and never bake secrets into layers. I order stable instructions early to maximize caching, scan the final image, and publish provenance or signatures where supported. The goal is a small, reproducible, auditable artifact. In your answer, talk about minimal trusted base images, multi-stage builds, pinned versions, non-root users, secret avoidance, vulnerability scanning, layer ordering, Docker ignore, reproducible builds, and image signing or provenance. Question 4. Explain Docker image layers and how they affect build performance and storage. Each Dockerfile instruction can create an immutable image layer, and Docker reuses unchanged layers during subsequent builds. A container adds a thin writable layer above those read-only layers. I place infrequently changing steps, such as system packages, before frequently changing source code, then copy dependency manifests before application files. Shared layers reduce storage and build time across images. However, excessive layering or oversized commands can complicate caching and maintenance. Be sure to mention immutable layers, Dockerfile instruction behavior, writable container layers, cache reuse, layer ordering, image deduplication, cache invalidation, and why combining or separating commands requires judgment. Question 5. What is the difference between CMD and ENTRYPOINT in a Dockerfile? ENTRYPOINT defines the primary executable, while CMD supplies default arguments or a fallback command. For example, execform ENTRYPOINT, Python, app.py, combined with CMD, port 8080, allows users to replace the port without replacing the application. I prefer execform because it preserves signals and avoids shell parsing surprises. A shell form entry point can cause poor termination behavior, especially when the application must respond correctly to sigterm. While answering, distinguish executable defaults from replaceable arguments, explain shell and exec forms, demonstrate override behavior, discuss signal handling, and recommend patterns for predictable application startup. Question 6. How do Docker volumes, bind mounts, and tmpfs mounts differ? Named volumes are Docker-managed storage and are my default for persistent container data because they are portable across container replacement and easier to back up consistently. Bind mounts map a specific host path, which is convenient for local source code development but couples the container to host layout and permissions. tmpfs mounts store data in memory and disappear when the container stops, making them useful for sensitive temporary files. Each choice reflects a persistence requirement. Make sure to cover persistence, host coupling, portability, permissions, backup strategy, performance, sensitive temporary data, development versus production usage, and practical examples for each mount type. Question 7. How would you troubleshoot a container that exits immediately after starting? I first run Docker PSA and Docker logs to identify the exit code and application error. Then Docker inspect reveals the image entry point, command, environment, mounts, and restart policy. A common cause is that the main process finishes immediately, so I verify the service runs in the foreground. I also check missing configuration, file permissions, architecture compatibility, and dependency connectivity. Finally, I reproduce interactively with an overridden entry point and compare behavior. In your answer, talk about Docker PSA, logs, inspect, exit codes, entry points, foreground processes, environment variables, missing files, permissions, architecture mismatch, and reproducing the issue interactively. Question 8. How does Docker networking work, and when would you use bridge, host, or overlay networks? Docker gives each container a network namespace and connects it through a virtual interface. The default bridge is suitable for basic single-host workloads, though I usually create user-defined bridges for automatic DNS-based service discovery and better isolation. Host networking removes network translation and can improve performance, but sacrifices isolation and portability. Overlay networks connect services across hosts, commonly in swarm environments. Published ports expose services externally. Container-to-container traffic usually needs no published port. Be sure to mention network namespaces, virtual Ethernet pairs, DNS-based service discovery, port publishing, isolation, host networking trade-offs, overlay connectivity, and appropriate single-host or multi-host scenarios. Question 9. How would you design Docker Compose files for local development and production-like testing? I define each service, network, volume, health check, and resource expectation in Compose, then separate development concerns from production-like settings using override files or profiles. Source code can use bind mounts locally, while databases use named volumes. I avoid hard-coding secrets and provide documented environment templates. Depends on control startup ordering, not readiness, so applications still need retries or health-aware orchestration. This structure keeps onboarding simple without hiding operational behavior. While answering, cover service definitions, dependencies, health checks, environment files, secrets, profiles, networks, volumes, override files, reproducibility, and why Compose dependency ordering does not guarantee application readiness. Question 10. What is Docker BuildKit, and how does it improve image builds? BuildKit is Docker's modern build engine, designed for faster, more flexible, and more secure builds. It can execute independent stages concurrently, export or import cache, and use temporary secret or SSH mounts without persisting credentials in image layers. I also use cache mounts for package managers and multi-platform builders when publishing images for different architectures. BuildKit improves developer feedback and C efficiency, but teams still need reproducible inputs and controlled cache sources. Make sure to explain parallel execution, improved caching, cache mounts, secret and SSH mounts, front-end syntax, remote builders, build contexts, multi-platform builds, and secure handling of temporary credentials. Question 11. How would you implement a multi-stage Docker build for a compiled application? I use one stage containing the compiler, dependency manager, and source code, then copy only the produced artifact into a clean runtime stage. For a Go service, the builder can produce a statically linked binary, while the final image may use distroless or scratch if certificates and runtime files are supplied explicitly. This reduces attack surface and image size. I verify the final stage contains everything required, because minimal images can make troubleshooting less convenient. In your answer, talk about builder and runtime stages, artifact copying, minimal runtime dependencies, static versus dynamic linking, debugging implications, cache efficiency, and verification of the final image contents. Question 12. How do you manage secrets securely in Docker-based applications? I never place secrets in Docker files, build arguments, committed compose files, or image layers because they can remain recoverable. For production, I prefer an external secret manager or Docker secrets where supported, mounting values as protected files with limited access. Applications should avoid logging credentials and support rotation without rebuilding images. Local development can use uncommitted environment files, but that convenience must be clearly separated from production controls and audit requirements. Be sure to mention environment variable exposure, image layers, build arguments, Docker secrets, external secret managers, file permissions, rotation, least privilege, logging risks, and differences between development and production handling. Question 13. How would you reduce Docker image vulnerabilities and maintain a secure supply chain? I reduce risk by selecting maintained minimal base images, pinning dependencies, rebuilding regularly for security updates, and scanning both operating system packages and application dependencies. I generate an SBOM, sign images, and preserve build provenance so deployments can be traced to source and tooling. C should block critical exploitable findings according to a documented policy, not simply every alert. Runtime controls, non-root execution, and rapid revocation complete the supply chain strategy. While answering, cover trusted registries, minimal bases, dependency pinning, SBOMs, vulnerability scanning, image signing, provenance, admission policies, patch cadence, non-root execution, and risk-based exception handling. Question 14. A customer says containers are slower than expected. How would you investigate and improve performance? I begin by defining the baseline and measuring CPU, memory, throttling, I/O, network latency, startup time, and application level throughput. Docker itself is often not the bottleneck. Restrictive CPU quotas, memory pressure, overlay file system behavior, bind mounts, or excessive logging may be responsible. I reproduce the workload under controlled conditions, compare host and container metrics, then change one variable at a time. Optimization should preserve isolation and reliability rather than merely improve an isolated benchmark. Make sure to discuss baseline metrics, CPU and memory limits, throttling, storage drivers, file system mounts, network latency, logging overhead, image startup time, profiling, workload characteristics, and controlled benchmarking. Question 15. How would you explain Docker resource limits and prevent one container from exhausting a host? Docker uses Linux control groups to constrain resources. I set memory limits to prevent a container from consuming the host, understand that exceeding them can trigger an OOM kill, and configure CPU quotas or shares according to workload priority. I monitor usage and throttling before right-sizing limits rather than guessing. Reservations and limits are especially important under orchestration because they influence placement. I also configure process and file descriptor limits where application behavior warrants them. In your answer, talk about C groups, CPU shares and quotas, memory limits, kills, reservations, swap, process limits, monitoring, right-sizing, and how limits interact with orchestration platforms. Question 16. What is the difference between Docker Swarm and Kubernetes, and how would you advise a customer choosing between them? Swarm is simpler to operate and integrates naturally with Docker commands, making it attractive for smaller teams and straightforward services. Kubernetes offers a broader ecosystem, richer scheduling, extensibility, policy controls, and stronger industry adoption, but requires more operational expertise. I would assess workload complexity, team capabilities, existing platform standards, compliance, and expected growth instead of prescribing one universally. Docker remains valuable for image creation, local workflows, registries, and developer experience regardless of orchestrator. Be sure to compare architecture, orchestration scope, ecosystem maturity, operational complexity, networking, scaling, security, portability, team expertise, workload needs, and Docker's role in modern Kubernetes workflows. Question 17. How would you design a CI/CD pipeline for Docker images? My pipeline builds from a pinned base and commit specific source, runs tests, creates an image with BuildKit, scans it, generates an SBOM, and signs the artifact. I publish immutable digest references rather than relying only on mutable latest tags. Promotion moves the same verified image through environments, preventing rebuild differences. Deployment includes health checks and rollback to the previous digest. Cache imports speed builds, but the pipeline must prevent untrusted cache content from bypassing validation. While answering, cover source validation, unit and integration tests, BuildKit caching, immutable tags, vulnerability scanning, SBOM generation, signing, registry promotion, deployment verification, rollback, and separation of build from release. Question 18. How would you handle logging, monitoring, and observability for containerized services? Applications should write structured logs to stdout and stderr so the runtime can collect them consistently. I avoid relying on files inside ephemeral containers. A central collector enriches events with service, image, container, and deployment metadata. Metrics cover resource usage and business indicators, while distributed traces connect requests across services using correlation identifiers. Health checks distinguish process existence from readiness. Alerts should emphasize user impact, saturation, and error trends rather than noisy container restarts alone. Make sure to mention stdout and stderr, structured logs, centralized collection, container metadata, metrics, traces, health checks, correlation identifiers, ephemeral file systems, retention, and alerting on symptoms and causes. Question 19. A Docker customer reports that a service works locally but fails in deployment. How would you diagnose it? I compare the exact image digest, architecture, environment variables, mounted paths, user identity, network access, DNS, and dependency versions between environments. I inspect logs, events, health checks, and exit codes, then test connectivity from inside the deployed container. Common causes include host-specific file system assumptions, missing configuration, startup races, or permissions that differ under a non-root user. I document the smallest reproducible example and eliminate differences systematically instead of changing several settings at once. In your answer, discuss environment parity, architecture, configuration injection, file system assumptions, networking, permissions, DNS, external dependencies, image digests, startup timing, and collecting a minimal reproducible case. Question 20. As a Docker solutions engineer, how would you discover customer requirements and recommend a container platform architecture? I begin with outcomes: deployment frequency, reliability, developer productivity, compliance, cost, and migration timelines. I map workloads, dependencies, state, traffic, security boundaries, current tooling, and team skills before recommending Docker Desktop, a registry, Compose, Swarm, Kubernetes, or complementary services. I validate assumptions through a focused proof of concept with measurable success criteria. My recommendation explains trade-offs, operational ownership, migration phases, and a realistic support model rather than selling technology in isolation. Be sure to mention business goals, current workloads, developer workflow, security and compliance, networking, storage, scale, skills, migration constraints, success metrics, proof of concept, and communicating trade-offs clearly. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.